And I've been looking at the net neutrality problem. So it's not that there are two kinds of filters or biases that can be applied to networks. There's the obvious kind. You go to a website and it doesn't work at all. And this is not so much of a concern. We can build laws and policies and figure out what we're going to do about the obvious stuff. It's the subtle changes that concern me. It's Bing is 50 milliseconds slower than Google. How do you know if this is the cause of an ISP, or if this is the cause of the millions of different routers that happen to be out there happening to be a little bit different? There is a risk of deniable alterations to the way the internet works. Things are worse, things are slower, but you can't prove it, and therefore you can't make policies, lead legislative policy around it. So, as an engineer, I thought it would be interesting to look into how do you detect subtle violations of network neutrality? How do you detect biased networks? And the core problem is we have all of these other routers mixed in, these other network paths mixed in, that could be causing the changes instead of the ISP. So we have to be able to filter those other hosts out. We have a way of making it so your net connection is actually a net connection from somewhere else. And that's what's called a VPN, a virtual private network. You're out all over the world, but you go back to your employer or some home network, and all your connections are routed through. Local ISP just sees encrypted traffic. We're going to do a slightly different form of VPN. In a normal VPN, your client sends traffic off to some machine on the internet, and then that thing talks to Google and Microsoft and Yahoo, and encrypts all the traffic back. And the new stuff, what I've written is called Neuter. It is the neutrality router, N00TER. It's just like a VPN, only when the server sends traffic back to the client, it's out in the open. It's totally visible to anyone who would like to see it. It is unencrypted, and not only is it unencrypted, I falsify the source of the traffic as if there was no neuter, as if there was no VPN going on. It looks to the ISP like Google is talking to some user, or Yahoo is talking to some user. Now, why would I want things to be out in the open? When I use neuter, when I use a VPN, really, all traffic gets collapsed back to a single route. It always takes the same path. It is normalized. I want the filter that would normally be applied to Bing to apply to my normalized path. I want the filter that would normally be applied to Google to be applied to my normalized path. And if I do this, I am able to see, hey, I have the same path, the same server, I'm getting two different quality of services. Why? Because something on my local network, something at my ISP has a bias. It makes all the other sources of change disappear, and we're left with the one cause, which is an ISP policy. And that's pretty much it. There are all sorts of new other tricks you're welcome to ask about. There's a little hack called roto-neuter that inverts the process, but I don't need to get into that. I basically, the long and short of it is this. ISPs can do what they want. I'm not here to, wax ecstatic on the effects of the economy by biased networks. As an engineer, though, I'm here to tell you whatever changes are done might as well be transparent, because we can certainly detect them with this sort of packet manipulation. That's what I got, and I'm open for questions.
So did you do a lot of tests in the cloud?
So I have a very strange approach to this. I'm not out to bust anybody. I work with a lot of network engineers. And I think at a lot of ISPs, there's the community that says we should provide the absolute best quality of service. There's the community that says, well, maybe there's money to be made here. And so at this point in Neuter's development, I am simply putting out the word that you shouldn't do anything you don't want to be on the front page of the newspaper tomorrow. I don't need to embarrass anybody. My dream is that neuter never finds anything. Now, obviously at some point, we're going to have a nice extensive list of what's going on out there. And in fact, as a side, I'm not the only person looking at neutrality issues. The FCC just did an open apps challenge, a revolutionary thing, where they just said to the community, hey, give us ways of finding violations. And I'm sure some of the other people are actually actively probing. Me, I want to express the end game, which is that it is impossible to make a filter that neuter ultimately can't detect. I haven't gone into the technical details because they're a mess. But what I want to be clear is that the defenses that one might deploy to make neuter unable to see your bypasses, those defenses themselves are easily detected. So there's a very much a damned if you do, damned if you don't, if you're a network engineer trying to prevent your policy from being discovered. Again, I hope that neuter never finds any policy. I much would prefer that anything that would actually be harmful or damaging to reputation is simply quietly shut down now that people realize they can get busted.
How are you spelling neuter?
N00TER. It is a pun on a couple of levels, but mostly on neutering filtering.
Does it stand for something?
No, it stands for neutrality router.
When is neuter going to be available, and then under what license will it be available? Will it be open source GPL or just free as in beer?
BSD license within a couple of weeks.
So
Sooner if you say, please send me the code.
Please send me. What is it? C++? Perl? What do you say?
Over the years I've gone over, DNS and web stuff and DNSSEC and all that stuff. Back when I had just graduated from school, I wrote a programming library called libpaketo. And I released a set of tools called the Paketo Kairetsu. Keiretsu. I haven't played with the old Paketo Kairetsu code in like almost 10 years. This is all written in C to that library. And it had to be because it has to be very fast. Because TCP, nerding out a little, because the protocols that we use have timers, and they expire if things don't happen in a certain number of milliseconds, if you don't write it in a fast language, it doesn't work.
Dan, so who is this scheme that you use? And can you just give me an example of how you would like to see it deployed? Like, where's it going to go? Am I going to have it on my laptop?
So the present deployment model, you put a magic box in front of your internet connection. Hook up a cable to your laptop, and that thing goes directly to your cable modem link, your DSL link, and so on. And then you just use the internet as normal. See, most network neutrality detection engines require you to emulate whatever protocol you're attempting to validate whether it's being affected by policy or not. It's a lot of work. It really is a lot of work to emulate BitTorrent, emulate this, and emulate that. Neuter operates the IP layer, so it works for anyone. If an ISP is preferring Xbox 360 traffic to PlayStation 3 traffic, neuter will tell you, because it's totally independent of what you're running over the link. All it says is, I'm going to go ahead and do this half VPN, half open stuff, and if traffic arrives faster when the IP packets contain X versus when they contain Y, neuter says, hey, look at the graph. Here's how fast these flows are, here's how fast these flows are. And they should be the same speed because they're coming from the same source and they're taking the same network path. So if they're not the same, then something's wrong with the network.